Hey everybody, this is part 15 of the processing tutorial. So last lesson we talked about classes and how to create an object, but right now things are probably still quite fuzzy on exactly what we're doing here. So I'm going to revise what we did last lesson, and then we're going to look this lesson at two already made classes, and we're going to see how you might create objects with them and how you would use those objects. So let's take a look at what we have with the ant. So the first thing we did was we created these two files. So notice this is kind of the main file where you see setup, and this is also where we'll put draw or draw loop and everything. If you pop over to ant, in here all we did was write class ant and put a start and end bracket. So everything that describes an ant is going to be in here. So in members, those are the attributes. When we create an object, it's going to have all of these members. So it might have the ant length or ant color or ant, aggressiveness or something like that. The constructor is what is used to initialize all of these variables. So it kind of sets up all the attributes, and it could do it in a unique way for every ant. So every time I create an object using the class, remember classes, it's like a blueprint that creates an object. We're not actually storing anything in the class. We're only going to be storing information inside the object that the class creates. And the constructor is kind of setting up all of those attributes. So in our case, the members will say all ants are going to have a size and a color. And then in the constructor would say, okay, when you create an object, for example, when I do ant1, and this is just declaring, remember I have to initialize it as well, and I'll show you that in a minute. But when I initialize it, the constructor gets called and it will say, randomly maybe pick a color for the ant. So it makes this ant purple, and it gives the ant a size of 20 pixels. Then maybe I come back here and I do ant2, and maybe I have ant and I make another ant. Alright, so now I have 3 ants. Each time for that object, when the object is created, it'll run the constructor, and for that specific object, it will create individual attributes for that. So it might make the ant 50 pixels and the next ant3 32 pixels, and they'll make them brown and silver respectively, or something like that. Okay, so once these are created, then we want to actually manipulate them and do things with the ants. We want them to draw to the screen, and we want to tell them to move left or right, or we want to tell them, oh, you've run out of energy, you need to stop, or maybe the ant has died, so we want to tell it to disappear. And that's why we have the methods, because the methods are all the things that ant can do, and we can interact with the ant using these methods. Alright, so I hope that gives you kind of a conceptual view of what a class is and what the objects we create with it do. And I just want to reiterate that one more time. The class doesn't store anything, it just creates the objects that will store information. So every time I do this, it's kind of like it's creating a whole copy of this somewhere in memory. So ant1, ant2, ant3 will all create copies of the class in memory, and each one of those copies is different from the others. Alright, now I want to show you these, and just remember to when comparing these are primitive values and these are objects, and the main difference is a primitive value only stores a number, like an integer or a float or a double or something like that. So it can also store a single character, but it can't do anything special, and we can't really add on any abilities to it, meaning it doesn't have methods attached to it, and it doesn't have members attached to it, and it doesn't have a constructor. So that's why they're primitive, is because they're very simple in what they can do, while an object created by a class is much more complex, and it has different abilities it can do, and we can extend those abilities by adding on to the class. Okay, so to kind of drive this point home, I'm going to look at this. So this is a class. Say I make a ball class, which we're probably all tired of seeing balls by now, but if I make this ball class and I give it these. So in a class, what would these be, do you think? If I come over here, would they be members, constructor, or methods? So take a look and think about it. What would these be? So if you recognize them as variables, then you would say they're members. So these are members of a class. So let's say I create 4 ball objects. So I use this ball class and it creates these 4 objects. And notice how they all have different sizes. And I mean, at the moment, they're all drawn in different places. And they all have different colors. So while the class shows this, each one of these balls is assigning different values to each one of these members. So this ball obviously has more red than this ball because it's pink. And this ball is all blue, and this ball is all green, and this ball is all red. So these values will all be different for each one of these. So it kind of has a copy. Actually, they do have a copy of their own X and Y, their own size, their own red, green, and blue variables. So inside here, inside this ball, there would be 6 variables, all of these, and inside here there'd be 6 variables, and in here 6 variables, and in here 6 variables. So in doing that, I've actually created 24 variables. And I can create as many balls as I want using this class. That's the power of a class, is being able to create multiple things, all with their own attributes, but they're all similar in some respect. All right, so I hope this gives you a little bit more intuition, and I hope it kind of drives home the point that the class is not storing information, it's the objects themselves that are storing information. So in memory, I'd have 4 objects. All right, so looking at this, I'm not going to fill anything in this lesson. What we're going to do now is I'm going to pop over to this other project, and we're going to look at 2 classes that are already created in processing. And the very first one is called PVector. And I'm going to say PVector P1. And we can look at this in the reference if we like. And if you come over here, this is under processing reference pvector.html. You can see an example of what a PVector is. And really all a PVector is a point. And I know people who understand what a vector is in linear algebra or calculus. You're saying a vector is not a point. Don't lie to people. But for our purposes right now, we're going to say a vector is a point. And if you want to, you can use a vector as an actual vector, of course. And if you don't know what a vector is, really all it is it represents something that is, it's like an arrow in space you can think of, and this arrow just points in a direction. Okay, so in our case, this is what a vector is. You can declare it like this, and you can initialize it like this. And this looks very familiar to our arrays. We have the new, and then we're saying the name again, just like we would have said float. But instead of having square brackets, I have these rounded parentheses here, and I have parameters inside of it. I have things going inside of it, numbers. And we're going to look at what that means. So take a look down here. You're going to say fields. And fields are another name for members, and in processing they're using fields, but you can also say members. And usually when you're talking about classes, the preferred nomenclature is members. So down here we have methods, and these are all the things that a PVector object can do. All right, so let's take a look at this, and let's try to make one ourselves. All right, so we're going to say PVector, and I'm going to initialize it here. I'm going to say new PVector, and I'm going to give it 50 and 100. All right, so this looks pretty good, right? We've got a vector. If I run this, it'll do really nothing. It's just going to draw this little box here. Let's set up this window up maybe with something a little more interesting. Let's do background is 0, and let's make the size maybe 500 by 500, and test it out. Good, we've got a better looking window there. All right, so I've got a PVector here. Now, before I do anything like draw anything with this, I'm going to show you how you can access the members of an object. So remember, PVector is the class, and P1 is the object. So P1 has all of these abilities that it can do. So you can normalize it, cross product, dot product. These are all things that you do with vectors. You can calculate the magnitude of the vector. and the magnitude would be the length of the vector. So if I started at 0 and I put a point at 50 and 100, the vector would say, what's the line? How long is the line from 0, 0 up to 50 and 100? All right, so that's kind of nice. It also has these members, and what I'm going to show you first is how to access the members. And you use this same technique to access the methods. So we're going to do a print line. We're just going to print something out, and you do P1 and you type a period and then you type X. So if I do this and I run this, down here you'll see 50 printed out. So I accessed the member X. And I can do the same thing with Y. If I access Y, it'll print out 100. So that's it. That's all you have to do to access the members. So let's try to use this now. Let's do the magnitude, and we'll calculate the magnitude. So when you access a method, you do the same thing. You type a period, you type the method name, and then you use these. Just like we were doing with functions, you use these, and sometimes you put stuff in them, sometimes you don't. So if I run this, I'm going to get this. So as I said before, if I have a point at 50 over and 100 down, so right here, and maybe let's draw that. Let's do point p1.x, p1.y. And can't really see it, probably because it is going to be black. So let's make it a line instead. Let's go from 0, 0 to p1.x, p1.y, and let's make this line the color of red. I'll make it green. Alright, so this line right here that I just drew is 111.8034 pixels. So this line would be that long. So that's nice, right? We just calculated the magnitude using this. Now, each one of these functions does something different. So this is like magnitude squared. It would calculate the magnitude squared. So if I did magnitude SQ, and it gives you the magnitude squared, and so on. So you could do each one of these. But I don't want to look at these in too much detail. Okay. It also has a nice thing. It gives you a random 2D unit vector with a random direction. So let's test that out. Actually, let's do p1.random. What is that again? Random 2D. And there we go. It gives me a random vector in 2D. So the first two vectors, and notice that it is a unit vector. I believe it's a unit vector. And it looks pretty close. Let's test it again and see what happens. Oh, maybe it's not. It's not a unit vector. It looks like it's just a random vector. Or is it? Nah. All right. So what we've got here are... Okay. So what we've actually done now is we've created this vector. We've used stroke just for the line. Remember, stroke does the outline color, so it works with lines. And we drew a line using the members of this object. So over here, this object has access to these, and you can assign them all. And I assigned just X and Y, 50 and 100, and I printed those out. And then I printed out, or I used this other function here to print that random 2D. So I used another method there. So there's lots of methods that you can use with every type of object. All right, and we're going to use this object in a little bit. That's why I'm showing it to you now. So let's look at another object that is probably one of the more useful things. Remember when I talked about arrays and I talked about how we can't delete things from them, and how once we make it, it's fixed at that size and we can't make it bigger or smaller and things like that? Well, the nice thing is there is actually a class called ArrayList, which does all the things that we would love to be able to do with an array. So in the past, I'm gonna draw a float array here. I'm gonna call this my float array, and equals new float, and let's make this 10. Okay, so notice this, once I've created it, it's fixed at 10 and it can only hold floating point numbers, can't hold anything else. But this up here is an object that has a lot of special attributes. Now I could show you this documentation, but it doesn't really give you a lot of idea of what it is going on with ArrayList. It doesn't describe everything in here. This works much better for describing what an ArrayList is. This is tutorials point. There's a bunch of random sites that will show you basic things for Java and stuff. Tutorials point has a lot of information, and I think it's pretty easy to just quickly look up stuff, and it's formatted well enough that it always has good examples. So look here, these are all of the methods that ArrayList has. Now ArrayList doesn't have any members that we can access. There are members in there, but you can't look at them. So you can only play with ArrayList using the methods. Alright, so it would be like if we went to our ant class and we took all these members out, so you could only really see the methods and you could use the constructor. So let's take a look at how you can do something with ArrayList. So all I need to do to add something to this is use add, and I can put 105 in there, or I can use myArray.add and I can add something here, and myArray.add, and I can add let's put an integer number in here now, and let's do something crazy, and let's say use PVector p is equal to new PVector, and let's call this 2020, and I can even do this, myArray.add and p. Okay, if I run this, there's no problem. I have an array and it has all of these things in it. Okay, so let's take a look and see what kind of things we can now do with the array. Alright, so we can add, that's what we did. We just added something. We could clear all the elements from it. It would erase everything in the array, and we'll do that in just a second. And you can check the size. You can also turn it into an actual array, meaning like an array that we have used. And there's a lot of other things you can do with it, and we'll take a look at some of those later on. But right now, let's just play with some of these. So print line myArray.size, and if I run this, it will tell me 4 because there's 4 things in there right now. And let's actually remove one of the things in the list. So let's do this now, myArray.remove, and let's remove the second thing on the list, and then I'm going to print the size again afterwards. Alright, so I've gone a little bit quickly through this, so let's step back. ArrayList is the class, PVector is a class, myArray is an object, p is an object. This single line declares and initializes this object, and this declares and initializes this object. There is a difference between these. Notice there's nothing here and there's nothing here. And we're going to learn why a little bit later, but you can just think of these as the initial values for the vector. So this vector will have an x member that's equal to 20 and a y member that's equal to 20. This array list has nothing that goes in here, so we're not doing anything special with it. It just sets up the object, and then we can use it down here and add things to it. So we use the add method, and add method expects us to put something in here that it's going to get added on to this list. And when we added it on, we got 4 things. So there's 4 things in there, and I could either print them out or I can remove one. So I'm going to remove one here using this other method, remove, and this is removing at the second index. So now I have 3 things in the list, and it works just like an array in the way that it makes boxes. So remember how I showed you the picture for the array early on. I talked about how array was just a list of boxes and you put things in those boxes. Well, when you make a floating point array, you make those boxes fixed, meaning you say I want 50 boxes, and I told you that was because they all had to be next to each other in memory. And that's true for arrays, but ArrayList can add things or take things away however you want. So it only creates a few boxes in the beginning, or however many you tell it to, and then it will just keep adding on boxes as you need it. All right, so ArrayList is actually slower than an array, but it's not going to be significant on most computers for most of the things you're doing. You're not really going to notice the difference. All right, so let's try to access something now at one of these points in the array. So we're going to use myArray. I'm going to use .get. And this is kind of like if I were to go like this, I, or maybe index 0. So what's at index 0? It's this number, right? So if I do .get and I get index 0, it should print out this number. So let's see. And there it is. It prints out 100.5. It prints that out. If I access index 1, it's going to print out something. All right. If I try to access index 2 and print this out, it's going to print out the vector 2020. Prints out my vector 2020. Now notice there's this there, and that's because that is the z member of this vector. And if you look back here, it had x, y, and z. So it's printing out all of these members for us. Okay, so we have looked in this lesson at how to use objects that already exist in processing. Next lesson, I'm going to talk about how to make our own objects and how to access their members. And I'm also going to talk about the constructor. And then I might touch briefly on how to make a method, but I kind of want to devote more time to that because it is much more complex than creating members in a constructor. All right, so this looks pretty good so far. I'll try to play with some of these some more and look at the reference here. I'll link to this in the supplementary material so you can come over and check out their example. If you're looking at examples on this page, this is actual Java, not the processing version of it, the simplified version. So it's going to look a little bit different. But if you do things like just take off this system.out, and it'll work just fine. Don't ever try to copy this void main, or you don't need to write public class or anything like that, because we're using processing, not Java. So you can use this code and it gives you a good idea because processing is based on Java and you can use most Java code in it, but you'll have some issues if you try to start copying these things directly over. Okay, that should be it. If you have any questions, leave them here in the comments or on the website. Thank you very much.